which needs to be accurately classified, then I can go for deep learning. Okay, so connect these two keywords. One keyword is uncertainty of data, and second keyword you should always look into is like whether the data can actually temporally grow with time. If both is available, then deep learning is a good solution. Transfer learning is generally used in cases when you have only smaller amount of data. For example, you know that the data will grow in size in the future, but today you have only smaller amount of data. So how do you actually develop a model? There people suggest you can go for transfer learning. Now what you see in the below part of the slide is a diagrammatic representation for a neural network, basic neural network. So here you can see that there are a lot of inputs. Inputs are understood as I1 to IN. Each inputs are correspondent with the weights. Weights are called as W1 to Wn. So the product of the weights and inputs, which is W into I, summed up, what you will get is a value called as X. Every time you check whether X is greater than threshold, if X is greater than threshold, based on it, you can classify it to a class. Now I'm putting you a keyword in front of you, which is called as class. Okay. Now let's see the way in which a deep learning looks at. Right side, what you see is a diagrammatic representation of a deep learning model. Deep learning is again similar to neural networks, but has distinct differences. Let's see the differences. Deep learning also says it is diagrammatically represented in form of neurons, as you see in the diagram. Deep learning has something called as input layer, and deep learning has an output layer. So data is fed in the input layer and prediction happens in the output layer. So first two keywords are understood. Now the middle, what you see is something called as hidden layer. As you can see the keyword called as deep learning, it means deep. That means you can have more number of hidden layers. So if you ask your brain how many hidden layers you have in proportionate to what you know, right? Same thing here. You can increase the number of hidden layers. The more the amount of hidden layers, what happens is the better the learning, right? So the hidden layers will give you a higher level of abstraction in learning. So what a deep learning does, it's like this. It takes a set of inputs. Along the inputs, what it does is it is given to the input layer, then it's given to the hidden layer, and it goes to the output layer. At the end of the output layer, what it calculates is something called as loss, right? So loss will be the difference between an expected and the actual, right? For example, if you give a cat image, you expected the model to predict a cat image, but it might predict it as a cat image with a value of, let's take, zero point 0.1. So there may be a loss associated with that. So that loss will be calculated in the output layer. So if you believe that your loss is reached, then you can stop in one iteration. Here iteration is called as epoch. If you feel that the loss is very high, then in that case you can go through the backward propagation. That means it goes through the back propagation process, and again it starts from the beginning, right? That means it goes to the epoch 2. When it goes to epoch 2, now there is a primary difference. If you go to neural network, all weights will be taken for calculation at every iteration, that is at every epoch. But if you're going to the deep learning, when it is go to the second epoch, what it does is it will not take all the weights. It will take only the weights that has participated to the learning. That weights alone will be assumed to calculate in the forward propagation. So now we get a new loss at the end of the second epoch. If you feel that the loss is still not reached, then you can retrain the model again. That means now we are going to epoch 3. It goes like this until your loss becomes minimal. So somebody asked a question, when does your deep learning model stop? There are two answers to it. One is in the coding part, you can say number of epochs is 50. That means it will run for 50 times. It will give you a model file. The other way of looking at the same thing is you can fix a convergence condition and you can say that when the loss has reached minimal, that means that for the last 4 iterations, it has not changed at all. You want to stop at that point, you can stop at that point and you can download your model. So this is how a deep learning works. So the primary difference between deep learning and neural network techniques is in deep learning, you have more number of hidden layers. When you come to deep learning, all weights will not be considered in the second epoch onwards. The third one, the deep learning stops when the loss becomes minimal. Now, usually people ask a question like, what sort of model should I take, right? Okay, what architecture should I take for deep learning? It is an answer related to your application. For example, let's take you are looking at an object detection. People say YOLO is good. So I can take YOLO 2, YOLO 3, YOLO 4, right? So answer to your question would be is like, if I want to take a deep learning architecture, choose your application. and then choose your architecture, because now we have got many architectures for specific applications. Even for medical image processing, we got architectures for a specific use case in medical image processing built on deep learning. Now let's come to this slide. As I told you, these three keywords are always connected: artificial intelligence, machine learning, and next is going to be deep learning. Now, before we move on to the next concept, right? We have to walk through to understand concept in principle. Now, what you see here is an Excel sheet, right? Ma'am, are you able to see? Okay, I believe people are seeing.
Yes, sir.
Right.
Yes, sir.
Yeah, okay. What you see here is an Excel sheet. Now, in this Excel sheet, this is a data, okay? I'm taking an example of, let's take a mark sheet. Now, you look at this mark sheet, you will understand that these are called as columns in layman term: roll number,
Sir,
name.
we can. Sorry for interruption. We can see your presentation, not the Excel sheet.
Okay, what is this? What will see the Excel sheet? Yeah, one second, one second.
No issue, sir.
Is it okay now?
Yes, now we can see.
Okay, fine. So we have roll number, name, M1, M2, M3. Each of them are called as columns in layman terms. Now, when you come to all learning approaches, right from data mining, each column is called as a feature. So, what are your feature names? Roll number, name, M1, M2, M3. So, how many features are there? There are totally 5 features. So, first keyword is something called as feature. The second keyword is feature vector. What is feature vector? Is combination of features. So what are your features? Roll number, comma, name, M1, M2, M3. This is called as feature vector. The next keyword is dimension. What is dimension? Is number of features minus 1. If you assume that you're going to take all the 5 features, the dimension is going to be 5 minus 1. That's going to be 4. Because when you talk about dimension of data, it is usually corresponding to an XY axis, right? So if there are going to be 5 features, you can have 5 minus 1. That's going to be 4 dimensions here. Now, the next question people will ask is like, okay, should I take all the features? Now, if I look at this data, I'm introducing something called as, let's take grade. Okay, I'm introducing a feature called as grade. So using some rule, what I do is the grade of the student is something like A, B, C. Yeah. So I'm putting up some grades, just for example. Now the question would come up like, okay, what is your feature vector? Now I have got 6 features. Okay, so I got roll number, name, M1, M2, M3, grade. Now, depending on the type of prediction I develop, not all features are required. For example, let's take a college wants to release only the results. Okay, when they want to release the results, they'll be interested to release roll number, name, M1, M2, M3. That means the feature vector size is 5. Now let's take the company is asking, give me all the students whose grade is less than, let's take F. That means I want students only whose grade is only A, B, C, D. Then that case, what will happen is this marks will be ignored, right? So what you will give it to the companies, you will give to the company saying roll number, name, and grade. Now, if you look at the dimension of the data has got reduced. Originally, we have 6 features. Now we have got only 3 features: roll number, name, and next is grade. This is one way of looking at something called as dimensionality reduction. The other way of looking at dimensionality reduction is give it to the approaches that you've learned in the theory. One approach should be a principal component analysis, or you can go for the autoencoders. You give it to the principal component analysis or the autoencoders. Based on the nature of data, you can say how many features you want to create. You can say I originally had 6 features, but I want to have 3 features. Then it will automatically reduce the number of features and recreate your data. So the keyword I'm keeping you for your learning is dimensionality reduction. Dimensionality reduction is given a data, reduce the features to a meaningful number of features, wherein the prediction accuracy doesn't change. Now, next keyword that all of us should be understanding is something called as class. Now, if you look at this data, any data that you're going to go for learning models always has a class label. But what might happen is there may not be any ground truth for the class label. For example, let's take you talk about a student performance. You don't know what is a rule to say it's a good student or a bad student. So the class label does not exist. So given a data like this where there is no class label being available, you want to give a class for it. Now, if you want to have a realistic example, if you ask yourself like, okay, today there's a lot of tests going on for COVID patients or non-COVID patients. Given a blood sample of a person, how are they able to say it is a COVID or non-COVID? If you go back to December, there was nothing called as COVID, right? Okay. But once the cases started coming in, there was a ground truth to say, given a blood sample with this characteristic, it's called as a COVID. So now you come to your learning models. You need to use algorithms which are from unsupervised learning if there is no data which is having a class label. Now this data is not having any class label. So I use an unsupervised learning algorithm. Let's take a k-means clustering. So using that, what I can do is I can give class labels. So it is like now I'm running a k-means clustering. Now the k-means clustering have classified my data to a specific class label. Now you look at the class label values. Class label values are 0 or 1. It is something called as a binary class problem. So the concept of classification is given a data using an algorithm of your choice from unsupervised learning, you need to classify to a respective class. Now the classification can actually go into three cases. It can be a single class, two class, or it can be multi-class. If you show to your kid a car, the kid knows only a car. Now, if you show a lorry in front of the kid will say it is not a car because the kid knows only it is what is a car alone. It is called a single class. Now, if you call your kid and show this is a car, this is a lorry. Now, if you show the lorry in front of the kid will say it is called as a lorry because the kid knows both of it, which is called as a car and also a lorry. It is called as two class. Now the same thing you can extend as a multi-class. I think people can understand. You can take a car, you can take a lorry, you can take a jeep, show all this in front of the kid. The kid can recognize whether it's a car or a lorry or a jeep. That means the more the amount of data you train to the model, the accuracy of classification is very high. Now, what you would have got to your mind is if I have a data where there's no class label, I can use an algorithm from unsupervised clustering, which can be a k-means, using which I can classify my data. Now, this data is something called as a training data. So the more the amount of training data is available, the better the amount of prediction will happen. So in theory or in research or in industries, what is suggested is the amount of training data should be at least 70%. If that means you have 100 records, 70 records can be taken for training and 30 records can be taken for testing. Now, we know what is unsupervised learning. Now let's come to the next case. Now I'm getting a data. Let's take it say 17. Okay. And it is giving me some values for the marks, right? So it says the grade is, let's take T, right? Now the question would be is like, what is the class it belongs? Now you have to take the help of a supervised learning because already you have a data which is having a class label available. So it is classified data. So you can get a supervised learning model. A supervised learning model can be k nearest neighbor with which you'll be able to classify the data. So the class it will try to fall in will be any of the class labels here, which can be 0 or 1. Now, this data is called as a test data. So training data will be 70% minimum in the data models and test data will be at least 30%. That means you have 100% data, you split 70% as training, 30% as testing. Some research papers always take 75% of training and 25% for testing. Okay. Now there is another category of algorithms which is called as boosting classifiers. Example of boosting classifier is AdaBoost classifier. If you want to minimize the number of outliers in your given data, you can go for a boosting classifier. Now in summary, this example is for you to know what is feature. That means every column is in the data is a feature. What is a feature vector? Group of features together is called as a feature vector. What is dimension? It's a number of features minus one. Dimensionality reduction, you can go into the data and you can change the data. Like I told you here, I can ignore M1, M2, M3 and keep grade alone. Number of features have got reduced. Or use techniques like principal component analysis, autoencoders to reduce the number of features. The next keyword is classification. For every row of data, you need to give a class label. If a class label does not exist, please go for unsupervised learning like k-means and give a class label. And training data will be 70%. Test data can be 30%. If there's a class of data with a class label available, then the test data or any data for prediction can be run with a supervised learning model. Example is k nearest neighbor. The other classifier which I have told you is boosting classifiers. Example is ADA boost classifier. Okay, this is a summary which I want you to keep it in learning here. Now, the other thing that usually people talk about is something called as intra-class and next is interclass. Okay, let's take somebody goes and says, I have a fever. Okay, let's call it as 0. I don't have a fever. Let's take a call it as 1. Now, the answer would be like, let's take somebody says, I have a fever, right? He falls into a class, let's we call it as 0. Then we want to know what type of fever it is, right? So let's take, you want to classify it as a viral fever, for example. Okay. Now, this is called as a viral fever. Now somebody goes and says, I do also have a fever, right? So let's take, doctor says you seems to have a typhoid. Now if you look at between viral fever and typhoid, they fall under the primary class label 0, right? So viral fever and typhoid is an example for a intra-class. That means both of them fall under the same class, which is called as 0. So when you come to classification, your problems might talk to you about something called as intra-class and interclass. Intra-class here in the sense viral fever and typhoid. Interclass here in the sense class label 0 and 1. Okay. Last point I am keeping for people to understand is, see, nowadays people talk about something called as real-time clustering algorithms. Data is coming live. I want to cluster my data. What type of algorithms can I go for? I can go for real-time k-means. Okay. Ma'am, can you see the slide, ma'am?
Yes, sir.
Okay, fine. Now the keywords should be understandable for all of us. Label means a class label. Machine learning algorithm, example is a k-means or a KNN. Data is any data that you want to process. Label data in the sense, originally the data do not have a class label. I run through a unsupervised model. I give a label for the data. Prediction is, if there's a training data which is classified, I give a test data. I'll be able to predict to which class it can fall. Now, any problem that you generally work falls into a classification problem. But sometimes based on the type of data, whether it's a discrete or continuous data, it can always fall into something called as regression problems. That is why researchers always say, please solve your problem first as a regression problem, then go to any sort of algorithms. It can be deep learning, transfer learning, or whatever you know from the learning approaches. The next is clustering. As I told you, if given a data, it falls into some class. If there are only 2 classes, it is going to be 2 clusters. If there are 3 classes, that's going to be 3 clusters, right? The last keyword which you can see is something called as anomaly detection. Anomaly detection is more corresponding to what is an outlier which we are looking at. Okay. Now anomalies are more about something which is of interest in the data, which has a business use case. Okay. Now, what is this that we talk about? It depends on the context of the data. Now, all of us are watching the COVID, right? Okay. Every day you are seeing the data with respect to the people getting affected in COVID. All of us are seeing a graph going up, right? Now, our question is like when it will come down, right? The point at which it reaches a peak and comes down, that's a point at which we should be looking at as a anomaly reduction. That means for us, anomalies, data is keeping on increasing. That means number of cases is keeping on increasing. If you can formulate a model for that, then you can say that I have developed a model for anomaly detection with respect to COVID cases in a particular place. Right. So when you come to deep learning, we have a very interesting keyword, something called as feature engineering. So deep learning as such was started with image processing concepts. So everything goes only as an image. Right side, if you look into the slide, we have got a cat image. Now, if you look at a cat image, what is a feature? Every pixel here is a feature. Now, group of pixels is called as edges, as all of us know. So a deep learning model will take a cat image, look at the features, combine all these features, and it will say, I have found something called as edges. So the edges that is formed is a feature that the deep learning model is able to find. This is called as feature engineering. Now the deep learning model in the next layer of abstraction, now you can look at the hidden layers. It might say that, see, edges together is called as region. So I have got a set of edges. I found a region, right? So it is a region 1. It is a second feature that it is able to find. So that is again an example of feature engineering. So the right side slide should be able to get you a clarity. Here what we talk about is a deep neural network, which consists of a hierarchy of layers, where each layer will transform the input data. Input data here is a cat image into more representations, which can be edges, edges corresponding to regions, regions corresponding more in the case of a cat, it's a nose or a face like that. The output layer will be able to say how much it is able to predict it as a cat image or not. So these are the keywords that we have already concluded: features, feature vector, dimensionality reduction, class label, and classification. Now, when it comes to deep learning, this would be the key takeaway points that we all of us should be understanding. The first one is something called as filter. So what is a filter? Filter is generally called as a neuron. A filter is called as a kernel. So what a filter will have is something called as weights. Now, what is this? How does it help us? See, if you give a cat image, I just want to find the edges. That means I want to find the pixel points which can be connected as called as edges. So there is a filter requirement for it. The filter will have a set of weights. Now, the filter as such can be called as feature identifiers. Reason is, as I told you from the cat image, I can find edges, regions, colors, any open curves also. So each set of features can be found using a filter, which will have something called as weight values. Then depth of the filter will be same as the depth of the input image that you've taken. Now let's take an example. If you have an input image, assume it's a color image. The size of the image is 32 cross 32. Since it's a color image, we got one matrix for red, one matrix for green, one matrix for blue. So you have 32 cross 32 cross 3. You have a filter with yourself. The filter is 5 cross 5. Again, it's 3 matrices RGB. So it is 5 cross 5 into 3. After you apply the filter on the input, what will be left out will be again a square matrix, because an image is a square matrix. What will be left out will be 28 cross 28 cross 1. This is something called as an activation map. This feature map or the activation map will carry the information for classification. Now, along with this, there are two main other operations that are tried. One is called as stride and next is called as padding. Stride as such will say how you want to apply your filter over the input volume. For example, a filter can be applied anywhere on the image. For example, all of you are looking at the monitor now. If you are having your face in the center of the screen, all times we would say that a filter can be applied in the center of the screen for a face recognition. If you always have a tendency to keep your face to the left side of the screen, we would say that keep your filter in the left side, because the face recognition will work for you properly. So this is what is something called a stride. So stride will say how can you apply the filter over the input volume. Next one is called as padding. An input image as such is a square image, but data is not like that. If you have a set of records, which is a records from a student data, like we started with an Excel sheet, it need not be a square matrix, but deep learning architecture needs only a square matrix. So what you can do, you can fill the remaining values as 0, and that concept is something called as padding. Okay. Then for detection or localization, we have specific architectures as I have listed in this slide, which is RCNN, fast RCNN, variants of that. Next, what we have is segmentation. For segmentation also, you can look at possibilities of looking at semantic segmentation, right? And you can look at shape-based approaches also. Now, a deep learning model as it is running, given input data, what it does is it has to calculate something called as a neuron. Now, each neuron value will calculate as a function of summed product of weight into inputs. Minus B is nothing but the bias. So the loss as such which we calculate is the difference between the expected and the actual. So what is expected and the actual? I'm giving a cat image, right? I'm predicting it as a cat with a score value of, let's take X. So I have predicted something, but the actual is a cat image. So this will have a definite score of difference which can be found out. So this is the difference of expected and actual, which is calculated as a loss. If the loss is high, as I told you in the beginning, the deep learning architecture will go to the second epoch, will continue to see whether it is able to learn better and again calculate a loss. This keeps on going until the loss becomes minimum. So every time in a deep learning model, what we will be calculating is a loss, which is the difference between the expected and actual, right? So backward process, as I told you, when you're going for the backward pass, since the loss is high, what we always do is we go back and we see the weights which has contributed to the model, and we redefine that weights alone, and we go for the forward propagation. So every deep learning model, when it goes to the second epoch onwards, it will go for a backward pass. Parameter update means the weights as such will be updated in every epoch. The advantage is, as I told you in the earlier, we are doing it because we want to reduce the loss. So this keeps on going until the loss becomes minimal. This is something like a gradient descent, which you would have learned in theory. When you are implementing a machine learning model or a deep learning model, then you will have some performance parameters. So what are your parameters? The first parameter is something called as precision. Second is accuracy. Third is recall, false acceptance rate, false recognition rate. Before we go inside this, let's see what something about the samples. See, your samples of data that you take can be either called as positive samples or negative samples. Positive samples and negative samples fall in the context of the data. For example, let's take you talk about the COVID blood test. There are a lot of people who are tested for COVID, right? But how do they say that that person is having a COVID or not? There is a predefined set of samples which are called as positive samples for COVID, and there is a predefined set of samples which says that these are all negative samples for COVID. So every data that you train will always have some positive samples and negative samples. So what is positive, what is negative samples depends on the context of the data. Now, if your positive sample given in the input is classified properly as a positive sample, then what we call as a true positive. If a negative sample is given in the input is classified properly as a negative sample, it's called as true negative. The complement to this would be something called as false positives and false negatives. Every time each deep learning model or learning models will be interested to work more on the false positives. Okay. Now, your TP is called as true positives, FP is false positives, TN is true negatives, and P and N is positives and negative samples. So now these are the general parameters that are calculated for machine learning. Now here, in my understanding, initially I used to take all the parameters for the models. Then I came to understand from my papers when I write and get comments, all parameters are not essential for all problems. For example, if you're looking at a face detection problem, let's say you want to detect it's a face or not, then you would be interested to go for precision recall. You can give a precision recall curve also. The other one, accuracy, where it will be important is if you want to accurately classify, let's take you want to accurately classify your face, and if it is your face, the application should open. There it is something called as accuracy. Okay, so work on your application. On your application, ask whether precision recall is important or accuracy is important. Okay, there's one more thing which people always use it, which is called as confusion matrix. The confusion matrix will give you an analysis of how the classes have been classified properly, right? So when you look at a confusion matrix, you are supposed to have values as a matrix output. What will be there is the rows and columns will correspond to the class label. So let's take your class labels as 0, 1, 2. So your matrix will look like what? Along your rows, you're going to have 0, 1, 2. And along your column, you're going to have it as 0, 1, 2. So the result of confusion matrix should have class label values only along the diagonal. That means 0, 0 should be filled, 1, 1 should be filled, 2, 2 should be filled for the given input samples. In case you find values outside, that means other than the diagonal, you are finding values anywhere, then that means it's called as misclassification. So confusion matrix is a very good approach to talk about how your class distribution has happened. In fact, people look at class confusion matrix to solve class imbalancing problems. These are the performance parameters that are generally taken from deep learning perspective. You can see some parameters new, like false discovery rate, which is 1 minus precision. Then you'll find mean average precision. You'll find top 1 error rate, top 5 error rate, like this. Now let's see what is actually the essential difference in this parameters. Okay. Now, if you look at this Excel sheet here, are you able to see the Excel sheet?
Yes, sir, we can see that.
Okay, fine. Now let's look at this for our understanding, right? How a deep learning looks at. Now we have some data for testing. So let's populate one more data here. Let's take 19 and next is 20. Okay. So we have some values. We'll populate some values for our understanding. 34, 56, 67. Okay. 45, 67, 89. Okay. Let's see the grades to be C and A at a very better level. Now, when you are coming to a machine learning approach classifies with a class label. So this is a 0, this is 1, this is 1. Okay. Now, this is the result after running through a model. Let's take is on k nearest neighbor. Okay. Now, usual approach what people do is people always ask a question, how do you say this is correct? Okay. How do you say this is correct? Now, what they do is like they will again run this data with a k-means approach and see what is the class label they are getting, right? With that, they will be able to say whether the classification is correct or not, right? Or this data as such might have a class label in the original ground truth which is given. With that, they compare and say whether it is correct or not. Now, our discussion is about how a machine learning does, how a deep learning is different. Okay, let's put machine learning and next is deep learning. Now, your machine learning algorithm says what? The class label is 0, 1, 1. Okay, but this data is already a classified data. Let's take it like this. In the internet, this data is already a classified data. So, as per the data, the ground truth is like this. The ground truth says the class labels as 1, 0, 1. Okay. Now, your machine learning algorithm has classified like this. Now, when you compare this with the ground truth data, every one of you will agree that the first one is not classified rightly because it is incorrectly classified as 0. The second one is incorrectly classified as 1. But third one is correctly classified as 1. Okay. So now if you look at the number of misclassifications, there are two misclassifications. First and second is misclassified. This is how a machine learning algorithm works. But a deep learning approach is more of a stochastic approach. It's more of a probabilistic approach. So what a deep learning algorithm will do is, will try to give you the class label values, right, in the order of probabilities with which it gives a classified. So it will say it is 0, but it is 1 in the next higher probability. Okay. This one is 1 in the next higher probability it is 0, right? Okay. And this one as such, it is 1 in the next higher probability it is 0. Okay. Now, this is the results from a deep learning side. Okay. Right. Okay. Now, a deep learning will give you class label values for all the classes with a probability score. For example, if you look at the first data, if I'm going for a top one accuracy, right? That means in the first class level, which is correctly classified. First one is incorrect. Okay. Second one is incorrect. Third one is incorrect. But if I go for the top two accuracy level, it will say that in the top two, right? You can see that the second one is correct, right? Then if you come to the next row also, it gets correctly classified. Third row, if I come in, it is already classified in the top one probability. So this is the difference between a deep learning and a machine learning approach. A deep learning is a probabilistic approach. It's a stochastic model. It will try to give you the possible classification score for all the classes, right? Now, if you look at this, people might ask a question, two class, anyway, first class will come, second class will come. It's not about two class alone. Any problem is a multi-class approach. So if there's a third class also, then the third class value also will come up. If there's a third class called as 2, it will give you what is a class score in the with respect to 2. So this might look as 120. Just for example, I'm saying this might look as 120, right? So the advantage is you will be able to say that the accuracy is improved when you're going for the deep learning approach. Okay, so that's why you have new parameters in the case of deep learning. When you're going for deep learning, there are some stages in deep learning. First one is you do a data collection. The second one, what you would be doing is you'll do some pre-processing on the data. Now, pre-processing is looked at different perspectives from people's side. Pre-processing as such, one answer to pre-processing would be like, I'm looking for the missing values. Suppose I say that this value is missing. Then based on the grade rule, I might take the values of M2 and M3, and I would say that the value of M1 is 55. So this is one example of looking at missing value. The other concept of pre-processing would be is looking at noise. For example, let's take here, I got a mark as 134, right? But by ground truth, I know very well that mark can be maximum 100. So I use the ground truth to say this is not 134 and this is 34. So the noise is eliminated. But as such, when you talk about the smaller data, this is very easy because you can find the errors visually. But when it's a larger data, it's not like that. So people have developed approaches for handling noise. The most prominent type of noise which will come in the data is something called as Gaussian noise. So noise as such, we talk about uniform, non-uniform noise. And more detailed, we talk about something called as random noise. So if it is a large data where there are 100,000 records, you cannot go and find every cell and check whether it's an error or not. So you can use the models to eliminate the noise, right? So data pre-processing is now discussed. The next one is parameter assignment for deep learning architecture. See, when you say that I'm developing a deep learning architecture, people talk about the general parameters, like at least for understanding, people accept that there's something called as layers, right? So you would say that, okay, what is going to be the number of layers? So you'd ask like if it comes to layers, if it is a convolution neural network, as a very best example, you would ask how many convolution layers are you going to have? How many pooling layers you're going to have? These are all called as parameters. Now, certain keywords are fall under hyperparameters. What is hyperparameters is which can vary, right? It is not a fixed value. For example, learning rate is an example of a hyperparameter. Activation function is an example of a hyperparameter. So when you develop a deep learning architecture, you have to go and find out what are the parameters, what are the hyperparameters that you're going to tune in the model. So given the set of parameters and hyperparameters, you will have to go and test the model and check what is the accuracy of the model. If the accuracy is good, then you can conclude that you can start using the model file for prediction, right? So this parameter assignment, parameter tuning goes together. Now the new scope of research is now people are talking about bio-inspired algorithms to fine tune the parameters rather than saying the learning rate is 0.01. We can use a bio-inspired algorithm to fine tune and say the value is 0.01, right? Okay, so parameter assignment and parameter tuning is now going together with a lot of new algorithms. Stopping criteria, I've already told, when the loss becomes minimal, you can stop your model, or you can develop algorithms to fix your convergence criteria and say your loss is acceptable and you can stop the model. Visualization is in form of plots. It can be bar chart or it can be plots. We got a lot of plots with respect to deep learning. So this again depends on the software that you work. You can go to matplotlib in Python. You can see the different plots. Tools in deep learning, there are many tools. So it's again left to people. People want to start with MATLAB, you can use it. People start with Python, then they come with Keras and Theano. Some architectures are built on Keras and TensorFlow. PyTorch is also used. If you're working with image processing, people go with OpenCV because you need to write a lot of programs with image processing. But above all, what usually I say to people is now there are a lot of architectures developed for most of the applications. Let's take you're looking at a face detection, right? And if there is an architecture that is called as FaceNet, which is already available on deep learning, take that architecture that will be built on some programming platform in Python. Use that and then start thinking what is the limitation of that architecture and try modifying that architecture. That will minimize the effort that you can do to start your first problem. it can be project or research also, right? Data collection is always a challenge. People say that I'm not having data, I have to create data and so on. So what I say to people is like, you should actually have algorithm libraries which are written for generating a data, right? Now, for example, if you look at your data that you have in your Excel sheet, you would say that data is numeric. Sometimes data is also characters also. Like I told you in the previous discussions, that Excel sheet is having a data called as grade, which is a character. You cannot compare two rows which are which are not numeric. So there people use something called as one-hot encoding. One-hot encoding. So one-hot encoding is an approach to convert a categorical data into a numerical data, right? Now, if you don't have the data, try to collect data through different sources. Or one possibility is like, if your data is small, try to go to transfer learning, make it as a larger data, and then start working on the model. If it is image processing data, people will agree that in deep learning architecture, there's something called as data augmentation. Using that, you can actually have different transformations on the same data, right? So given a data, it will run through different operations. Like for example, a rotation. It will say that I'm rotating every 30 degrees. So if it is 12 images that you can get at 30-degree interval, so a given image, now you got 12 images out of it, right? Okay. So data you might not have in a bigger size, but you should know how to make it as a bigger data without reducing the characteristics of the data. This is one thing which is always very important. People think that features are features, but in a problem, you need to create new features. For example, if you talk to a doctor, the doctor will say the tumor region is very high. So what is that region? It's called as the area, right? So based on your problem, you need to create new statistical features, and that features can also improve your model approach. Okay, so what are statistical features? All of us will agree. Your statistical features are mean, median, average, like that. But in case you have lost yourself in understanding statistical features like that, then what I say to people is like, you should look at a website called as xuru.org, right? xuru.org, which is a very good website where you can learn statistical concept. So with that website also, you can try to understand what your data is. I'll show you here, right? So xuru.org. Okay, madam, are you able to see, please?
Yes, we can see the website, sir.
Yeah, there'll be something called as statistical tools in the left side. Okay, if you go to statistical tools, you click on descriptive statistics, you will get a text box. In this text box, you can type the values. This is something like feature in a given data. Okay, now once you give this values, now you scroll down, you give calculate, you give calculate, you'll be able to find different statistical features. So some features all of us know, mean, median, standard deviation, all that. But certain other features are also important, like kurtosis, right? All this you would have learned, but in case you have lost touch, please go back and learn the statistical features. Why do we do this is basically to understand about the nature of the data. And next, when we are doing test measure, we'll be able to see the goodness of the test also using this. And more importantly, you can talk about how the data is, right? What type of distribution it follows, with what confidence level, can be done using the statistical approach. So please have a look at this website. Then next one, which I always ask the people to have a look at it, is on the distributions. Because when you come to classifiers and algorithms, you'll have algorithms which is based on distributions based, right? So again, it's probability distributions. So you'll have different distributions that you have to know. You can see the list of distributions. Whichever you are not very clear, please go back and learn the distributions. This will help you when you learn algorithms like Bayesian classifiers, deep Bayesian neural networks, and so on, because all of them will look at distribution functions as a very important factor. The next one is, any problem that you solve can be solved as a regression problem. So you need to learn regression. Regression is very important for even for deep learning. So Variant of it, one is go with a linear regression. People say I got something called as multiple linear. You should know at least linear and logistic regressions, right? Because most of the problems are solvable as a regression model, right? So if you come to linear regression, just a quick information for you. It is something like this. Given a data, we want to work, we want to formulate a hypothesis. Okay, a hypothesis is something like this. If you have an xy axis, all of us are able to visualize. I have some points there. I want to draw a line and I want to separate the points. So the line will follow an equation which is generally called as y equal to mx plus c. But when you come to hypothesis, what you would be getting is you will get an equation which is y equal to mx plus c plus error. The error will allow you to classify and say whether the data is a positive sample or a negative sample. Now, if you provide a data here, okay, let's take you provide a data here. Forty-five, 56, and give a calculate. You will get a line equation which is like y equal to mx plus c, and you will get an error component. That's what I was saying you, y equal to mx plus c plus error. This error will allow you to say the nature of data, and it will allow you to find out or talk more about the outliers in the given data. And regression as such, each regression approach will talk about its performance in terms of its parameters, like correlation coefficient, residual sum of squares, coefficient of determination, like that. So one regression model will be compared with other regression model using these parameters. So request the audience to always look at regression. This is one good website which I have come across, right? Which will take you and make you understand about regression approaches, right? Then the next one, which I want people to look at would be is this one. Yes. This is a website on the internet, which is an online one. So this is just to understand how a deep learning works. We have been talking more about theory in deep learning. So we have been saying in the theory that there's something called as data. Ma'am, are you able to see, please?
Yes, sir, carry on.
Yeah. So that is something called as data. So we got data points here. Click on whichever data point you want. So each of it corresponds to a type of distribution in the data. Now, if you look at this data, all of us will say that this is 4 clusters. Okay. But if you look at this one, people say that it cannot be classified with a line, right? And if you look at this one, people say it is very simple. You can have a line equation and you can segregate it. You look at this one, this is very challenging. Okay. So data in higher uncertainty, if you ask me an example, this is higher uncertainty type of data. A data, if the lower uncertainty of data is this one, because the classification is easier. So you can take whichever you want. Let's take, we look at this one, 4 clusters. Then a deep learning model will ask you what is the ratio of training to testing data. As I told you, preferably have it as 70-30. It'll ask you what is the noise. So as I have been saying, noise can be found using the particular techniques. You can look at the techniques for noise reduction. So you can go for batch wise training. You can say what's the batch size that you want to go for. Then next one, if you come up, you can see something called as a learning rate. This is where hyperparameters and parameters come together. So learning rate is an example of a hyperparameter. You can set your learning rate. You can set your activation function. See, this is other difference between machine learning and deep learning, or neural networks and deep learning. Neural networks as such gives you models to work on linear activation function, but deep learning works more on the non-linear activation functions. Common activation function in deep learning is ReLU, selective activation function. You can say what type of regularization you want to have. You can fix your regularization rate. You can call whether your model is going to be a regression problem or a classification problem. As I told you, based on the type of data, discrete or categorical, you can actually look at either as a regression problem or a classification problem. So I'm calling it as a classification problem here. Then what we can do is you can go and click this. This speaks about features, right? So what features you want to have? So you can increase your number of neurons, right? You can increase your hidden layers. So as you keep on increasing your hidden layers, at each hidden layer, you can increase your neurons. Okay, I'm increasing my neurons. Once we completed this, then the last step, as I told you, it goes through a forward propagation and then it comes to the backward. Every time it calculates a loss. Now it shows a losses equal. Can you see here? Training loss and test loss. Test loss is 0.524 and training loss is 0.515. Now when I click, now what happens is it starts running. That means epoch is increasing. At every epoch, what happens is the loss changes, as I have been discussing to you all. So it will keep on going and it will converge at a point where the loss becomes minimal. When it converges at a point where the loss is minimal, what we have created is a model. That model file can be used for prediction. Now, when do you stop it? As I told you, you can give number of epochs as fixed and stop it, or you can leave it to the model to converge using some algorithms. It could be bio-inspired algorithms also. Okay, right. So architectures in deep learning, this is people have always questions about what architecture should I go for. I always suggest whether you can go for either you can go for deep learning or you can go for variants of deep learning also. So people talk about transfer learning also nowadays. Or if you are a beginner in deep learning, please study convolution neural network properly. That means you should learn the theory, plus you should look at how the theory works for a data. Because a CNN works for an image, right? But when you are given a data of, let's take healthcare data, or you are given a data of students' mark data for a mark analysis, can you apply a CNN? That is where your mapping will have a doubt. So request everybody to do a manual workout of a CNN against data which you have it in an Excel sheet. Then you look at any architectures which you want, which can be YOLO, RCNN, ImageNet. It's up to you. So in the process with Amrita, with my students, Mukesh and Rahul, we have developed one tool which is called as a metadata tool. This tool we have presented at a conference in Japan. So the purpose of the tool is more around if you give some data, how do you do a classification and a prediction on the data? It is more semi-automated. This tool is an academic version. We will try to take it to the academic community for usage more in the higher level. So what we have done in this tool is built on Python in .NET framework. So the advantage of this tool is if you give a data, it will itself go for a set of steps. For example, it will do pre-processing. It will ask you, should I go for dimensionality reduction? If you say yes, it will ask you, should I go for PCA or autoencoder? If you say PCA, it will automatically go for PCA and it will give you a reduced data. Then it will ask you what type of classification you want to do. If you say allow the tool to select, it will itself say it is a regression problem. Please select regression. If so, what type of regression? So it is like somebody wants to play around with the data, right? So the tool is developed. This we got some input from the industry people. Industry people told that see, not every time we can run a code and understand the data. If there is a tool which has got a reasoning capability and say this is a regression model, you can run this regression model and then do more of an analysis later, then it's more helpful. So that's why we developed this tool. This is an academic version. Slowly we'll host it on the internet for usage. Now, the next one which people usually ask is like, okay, how do I start with deep learning? What can be the nature of data? There are many data sets which are there in the internet, right, which people can use. One is if you talk about images, people will appreciate that there is something called as a Caltech data set, okay, which is a very good data set for working on image processing. So Caltech dataset is a very good dataset. So people can work on Caltech dataset. This is advantage of this dataset is it has got 360-degree perspective for every images. Right? Okay. If there's one chair, there will be 360 images for the chair. That means every 1 degree they have taken an image. Okay. Then next one, which I usually suggest is this one, this outlier detection data set. This is one thing which I usually suggest to people. This is a very good data set from Stony Brook. The advantage of this data set is this has got different categories. It's got time series data, it's got video processing data, it's got data with respect to events, activities like that. This is one other data which people can look on. The third one, everybody knows Kaggle is a very good data set repository. where you can find most of the data sets. Even the data sets with respect to COVID is also there for Kaggle, which people can start working, right? Other than this, with our campus and Amrita from the Smart Space Lab, we also have a public data set repository similar to um, what you have seen in Caltech. The advantage of that data set is we have got repository of data with respect to objects, fire, smoke, and so on. We will also be trying to share it in the public in the near future. Then next is when we learn theory and we talk about all these theoretical approaches, then the next question is like, okay, how do I look at a specific application? See, every application has got some solved and an unsolved case. For example, the first application I'm keeping before is face detection. All of us will agree that it's a solved problem because you open your camera, there's a contour region coming around your face. But all of us will agree that if the face is having a lot of shadow, sometimes it's not coming correctly. Or you can also go back and check. If you take a group photo and try to see a face detection there, sometimes what happens is two faces together standing in the group photo will come as one single region. So there are some problems still left out with face detection. The other one, if you want to formulate it as a use case in the real time, there are a lot of people lying on the road, right? It may be a reason that they are into some sort of health problem, or they are unconscious, whatever it is. But cameras are coming up everywhere in the regions for security purpose. If a camera can pick up somebody's face who is lying on the road and send a message to the nearby hospital or a police station, that might save a person. Whatever may be the reason he is lying, let's leave it. But the advantage is it is a face detection problem for helping a human. But there the challenge is a person who is lying on the road will not show his full face, only partial face is seen. Or let's take it as little dark, only half a face or a part of the face region will be shown. So there is a lot of face detection problem there, and there is shadow detection also will come up. Is one thing which I keep it. Next one is malpractice detection. This is one problem that we worked with 4 to 5 years back, but that was slightly at a very lower level. We had a camera in the class. We took a live video. We saw who are all the people passing papers. So passing paper is copying again. Who raise the hands, it is again copying. So that is what we tried. But now it is more important. I think people will accept that the way we are doing online exams getting conducted in online schools as such. There's a lot of possibility that the student might have a paper in front of the laptop at the back side, which somebody might show, which he might look and he might try to write. So can you go around the face region, again see the face orientation, go with the eye orientation and connect and see that, okay, this person is not looking steady. So he seems to be copying. So it's a malpractice problem which people can look at. Healthcare, COVID is a very important problem people can look at. Network intrusion detection, this is one thing which we are trying to solve with my team. Still, it's got a long way. What we are trying to do with a funded project from IBM is we are trying to take packets in the network. We are trying to build classifiers on deep learning, which will actually find out the malwares in real time. Okay, so that's again network intrusion detection problem, which people can think of doing. Agriculture is an open challenge. People should be accepting that in a land where there is sensors, right? Now people are talking about insects coming around to the land, trying to damage. So can you find out the insects as it is coming, make the sprays started automatically sprayed? Rather than the insects come, humans go and spray. Can you have sprayers there? Once the insects are more in that region, can the sprayers spray more pesticide there and destroy the insects? So there's a lot of scope there. It is again a region-based model, because if you have a land of a small region, let's take around 10 cents or 15 cents, it's not a problem. But if you have, let's take 20 acres land and insects have come around every region, right? Can you look at automatic sprayers which will try to destroy the insects, right? That again, it's image processing. A region-based thought process can be taken there. Last one is call taxi booking. This I say to people in every of my discussions in most of the sessions. This I say because people should accept that whatever you develop is not only a model, it has a business use case. Like for example, let's take you're booking a taxi and that one taxi is there 1 kilometer away, and there's another taxi which is 3 kilometer away. Your thought process is A taxi which is 1 kilometer away will be getting a booking, right? But the other thing might also happen. A person who is 3 kilometer away, let's take he has traveled only smaller distance on that day. The taxi provider might try to book that taxi to you because he feels happy that he has got one more booking. Okay, right. So there are a lot of business use cases behind model development also. It is not only mathematical basis always forms a foundation. So that's why I put up call taxi booking here. So there are a lot of data sets which is there, which people can have a look at it for your understanding. So as I told you, Caltech is one good data set. Then Stony Brook is another data set. Then we also have a data set which we got from Amrita, which is on the Smart Space Lab, which is also open to the public. But we are trying to improvise the data set for discussions. So that's all from my side. In summary, I have left to you the understanding on uh, machine learning, deep learning. What's the difference between these approaches? How to take about a data and talk about features, feature vector, dimensionality reduction. Then I talked to you about deep learning architecture. Then I walked it through you on data sets and how to build a model. Thank you so much for the opportunity given to Dayanand Sagar University campus. I'll take the questions, please.
Thank you, sir, for sharing your knowledge in deep learning with us. I would like to thank you for sharing your expertise and time during your busy schedule. With your permission, I want to pose some questions given by the participants. I request the participants to post your question to the chat box. So we have a question.
Please, madam, go ahead, please.
Is LSTM a deep learning algorithm or not?
100% LSTM is a deep learning algorithm. Most of the data, which is basically as a spreadsheet data, okay, which is having a lot of features, can be solved with LSTM. LSTM is a deep learning algorithm, 100%. This is the library that we have hosted from the Smart Space Lab. If you go to internet, it will be there. This will have different type of data, fire detection, object detection. For electrical burst also, we have posted the data. This is a data that we have hosted from one of our funded project from DST. In this project, Dr. Lata Parmeshwaran, ma'am, she's a PI for the project from CSE department, and I'm the co-PI for the project. So the data set is created and open to the public for usage.
Okay,
Yes,
sir.
madam, please.
Sir, how does LSTM solves vanishing gradient challenge?
Okay, it depends on the data set. Can they, if they are very specific, can they, if they can write what is the data set they are working on, then I can clarify them.
Okay, okay, sir. And we have another question.
Yes, madam.
When we want to integrate DL techniques for mobile applications, it usually fails because it can't bear the load of computation. So, is there any way other than connecting to the app to the cloud?
Okay, okay. This is I think I didn't say this. Sorry. The thing is, see, building a deep learning model is it takes a lot of time, and running it with the data takes more time. Sometimes it results in the laptop systems not able to work. Okay, it crashes.
Okay,
The reason is it needs a lot of computing power. When you say that the number of epoch is 10, it stops at 10. When you say epochs is 100 or 10,000, now if the data given is actually an image, let's take it's an image, then it has to look at every pixel. Now, if you ask what is the size of the image, if this image is small, it is okay. If the image is very large, then it has to look on that many number of pixels in every training process and classification. So what I suggest to the people is usually I would suggest you to run it on a smaller size data, right? And then check whether your model is working properly. Finally, when you're accepted, yes, LSTM works properly for only a smaller data, but it gives me more better accuracy compared to the other architectures that are taken in the research papers, then that becomes your first success. Second part, what you have to do is you have to look at a higher architecture computing with facilities that we have or you have in your individual place. You might not have a GPU, graphical processing unit. So what I suggest to people is like you can go for Google Colabs and you can run your architectures, or if you can possibly try to take support of colleges that has got GPU facility. They might allow you to run your setup and they will give you the results. That's the only way of sorting it out. Or if you are very positive, then you can write to NVIDIA. There's a call in NVIDIA always in the year. NVIDIA call for proposals. If you go and search, you will get it. NVIDIA grant. Okay, if you go and type NVIDIA grant, you will
Okay.
get NVIDIA grant. You can write your proposal. It's just a two-page write-up. They will give you free NVIDIA cards. Okay, which you can keep it with your institution for years. NVIDIA grant, yeah.
Okay.
NVIDIA grant. There's a call for proposals throughout the year. You can actually type for, yeah, you can see here, no? Higher
Yes,
education
yes.
and research grants. You'll get free cards, which you can take it back to your systems and you can run your applications. Or if you have money in the department or at your setups, you can purchase one rack server. One rack server will cost you around 3 to 3.5 lakhs with 1 terabyte storage minimum. That's it, ma'am.
Okay, sir. Sir, another question is, how does forward propagation and back propagation work in deep learning?
Yeah, forward propagation, actually what it does is every time it finds the sum of the uh, summed up weights and the inputs, and along with the bias, it calculates the output value. So that's what forward does, right? Backward propagation, there's a formula for back propagation rate calculation, ma'am, through which the weights will be iteratively reduced.
Okay, sir. Sir, is there any best book for learning and teaching deep learning concepts?
Okay, very good. Deep learning as such, better to go with the online lectures, but there are a lot of books coming up. Yesterday also I saw one book from deep learning from professor in VIT, which is released in Springer. But I would suggest a positive way would be is to go from online materials. As such,
Okay.
I'm not suggesting any deep learning book. I've not come across. Maybe that with my limited knowledge, that's my suggestion.
Okay, sir. So, will you suggest any topic for research in the field of deep learning? It's a question from participant.
Okay, fine. If you are in an academic institution, what I would suggest is activity recognition is very important in uh, any data. Now, most of the institutions have cameras. So, what I would suggest is any activity which is abnormal is an abnormal activity, which is an anomaly. For example, let's take your cameras can pick up and say there are 10 students standing in a place. It's an abnormal activity during the class period. Let's take the classes between 9 to 12. 10 students are standing out. Whatever may be the reason, it's an abnormal activity. You can look at activity recognition as a very good scenario. There are a lot of algorithms for activity recognition, and you can connect it to this use case wherever there are 10 people standing. Don't worry about who is standing. It should send a message to the security or the principal or the advisors. If it is more specific, it can go and find out who are the students standing outside. It can send a message to the advisors also.
Okay, sir. And they have a doubt which topic is better for research, machine learning or deep learning?
Okay, very good. Actually, if I would always say like this, as I told you in the beginning, if you had been in December 2019, if you had started working with the COVID problem using machine learning, you are the first person to succeed. If you're done with
Yes.
deep learning, you would have got more appreciation because that is also correct. But now, if you ask, it's a solved problem, at least to some level, right? So any
Okay.
architecture that you develop needs to be accurately classified in a more better manner. That is how you should always look. So in your application, the state of art has reached deep learning, and there's a lot of justification that the uncertainty is very high. You can start with deep learning, maybe you can come to transfer learning or federated learning also.
Okay. Can we ask some more questions, sir?
Please, ma'am, please, no problem. I'll
Okay.
answer as much I know. That's all.
Okay, sir. So, can we use deep learning in biometric images like palm print? What
Yeah,
is
it
the
is.
what is the
Yes.
best tool for that?
There's nothing called as best tool, ma'am. The coding as such has to be done in Python. They can use Keras and TensorFlow because TensorFlow is built on C++. Most of the palm recognition libraries are built on C++. So at least by that justification, I would suggest them to go for Python, TensorFlow with Keras.
Okay.
And they naturally will try to embed it to some embedded device, right? It's an IoT
Yes.
application. So Python is best for it.
Okay, fine. Thank you, sir.
Yes, ma'am.
How to improve the performance of machine learning, deep learning algorithms for research?
Okay, improving performance can be always done in two ways. One, in theory, what people suggest is add more amount of data. Okay, that's one way. The second one is every model will always have a loss in performance because of pre-processing. Pre-processing here in the sense, as I told you, noise or missing values, all that. If you can look at noise algorithms, noise detection algorithms, now there are deep learning architectures for noise detection also, right? If you can look
Yeah.
at noise detection algorithms there, the model improvement can be there. Then some model performance will be less because of class imbalancing. If you can go by some techniques and reduce a class imbalancing approach, then the improvement can be there. Then what people suggest nowadays is go for the multimodal learning. That means use a k-means clustering to fix the cluster centers, then run a deep learning and try to do a prediction.
Okay.
So you are using k-means with a deep learning. That means it's a multimodal architecture. There also the improvement is being kept. After all this, it's left to the application, ma'am.
Okay. Thank you, sir.
Thank you, ma'am.
Why GRU is faster as compared to LSTM? One question.
Okay, it's dependent on the architecture. They
Okay.
have their own reasons
Okay.
why GRU is better than LSTM. Actually, it is architectural principles.
Okay, sir. One question is CNN basically used for object identification?
Which one, ma'am? CNN.
CNN is basically used for object identification.
Yes, madam. Yes.
Okay. Can we use deep learning for soil pH value analysis? One question.
Deep learning for
Soil pH value. Soil
pH.
pH
Is
analysis.
is it if it is related to agriculture 100%? It falls under precision agriculture problem.
Okay, sir. I think we have covered most of the questions
Okay, ma'am.
from the participants. Thank you very
Okay.
much for
Thank you, ma'am.
clarifying their doubts.
Thank you, ma'am.
Uh, I I request the participants to fill the feedback form. The link has been shared to the chat box. Once again, thank you all for joining us today. Today's afternoon session details will be sent to your Telegram WhatsApp group. Have a nice day. Thank you.
Yeah, thank you, participants. Offline also, you can take my mail ID and you can reach in mail as you have seen in the presentation. Okay. So thank you, ma'am, Ranjani ma'am, Maulishwaran sir, and faculty from Dayanand University campus. Thank you all.
You're welcome, sir. Thank you so much.
Thank you.